Hi everyone, welcome to another episode of Kicking It with Karan. Today I have Suri Bala and we're going to talk everything HPC. Hey Suri, thanks for taking the time to come on the show.
Absolutely, current pleasure. Thanks for having me.
Oh, cool, cool. Hey, so we go way back. Back in my days at Microsoft, we met, HPC community is really small. So I think everybody should already know you, but just for my audience anyway, go ahead and introduce yourself, what you do, a little bit about your past, what you've been doing as well. That would be helpful. So take it away.
Absolutely. So, primarily, Karan, my role is as a crash worthiness, engineer. Really, the crash fascinated me, and now, if I look back on my 20-year career, it's amazing the journey. A car would take, I don't know, 5, 6 years to make one, put it on the market, but today I think there's tremendous pressure to put it in just a couple of years. So our role is really how can we take the data from simulations and how could we turn that into decisions quickly? And that way you can iterate many designs. And my focus is really that now.
It's amazing to think that you just mentioned that it takes anywhere from 5, 6, 7 years to build a single car program today, right? So really, a car manufacturer would have to have like a decade long vision into like what they're doing and what they're building and all the models and potentially maybe even anticipate all the trends, right? Like whether it's higher emissions or lower emissions or whether it's electrification, etc. Like talk us through a little bit about that kind of process. I mean, are you working as an example with car manufacturers where they're thinking 10 years out?
Our focus really in ability to predict reality. And that's really a challenge. And you have many different softwares that can do that. And the automakers, the regulations are increasing every day. So now you have 30, 40. If you go back to 70s, there was just one regulation that you had to meet and you could really put it on the market. But today the regulations are maybe 30, 40, 50, and you can't really do it. So you really have to plan ahead to make sure all those regulations are met. And that's where I think HPC and simulations play a very critical, role for that.
Got it. So how do these regulations affect uh, the simulations, so to speak? Like, does more regulations mean more HPC simulations, or is it just you have the same amount of HPC simulations, but you're just doing things differently? Like, how is that related?
If you look at, let's say, 20 years ago, if you could predict a displacement at any point in the car, I think it was a good simulation. But today, that's not sufficient. You have to be able to predict how many spot welds are going to fail. You have to be able to predict, and in fact, failure is part of the design. So if you look at a small overlap, you have to fail certain parts to meet that criteria. So then failure is a big part of it. So that brings up how accurate are your material laws and the cost in computing those. So in a sense, although we are targeting a smaller duration for a car to be made, the challenge of reality prediction is huge, I think.
What's sort of the next phase in terms of everybody's talking about moving things to the cloud, and HPC is slowly but surely getting there. I mean, what are you seeing, and what are some of the things that you're working on? I'd love to hear a little bit more about D3 View as an example and how it helps customers, give them a single pane of glass as they're moving their journey to the cloud. Can you talk us through a little bit of that?
I think the scenario that we are seeing today is really, a combination of on-prem and a multi-cloud environment. And I think any solution that you provide has to work very well, where it can talk to an on-prem system. You're talking about hybrid, you're talking about multi-regions to having this access. And so that's, you start there. And then you're looking at multi-region, and then you have to look at data transfer issues. And so our philosophy has been really stay close to the data, of course, and run your analytics close to that data, and then streaming the information from that source to multi, regions, to multi, people interested in, as you said, the one vision. I think there your information can pass very quickly. And so really, at the end of the day, they can run more simulations, iterate quickly, and get to the optimized solution quickly. So I think that's the kind of scenario that we're looking at.
Got it, got it. And that means like faster development means faster car development, means they can get it out to market quicker, meaning they can make money.
Absolutely. And that's where Oracle plays a huge role. I think bare metal is key and performance is key. Even if you can get 20% reduction, and let's say your simulation finishes at 7 o'clock as opposed to 5, then a difference of 2 hours can really make a difference, where you can spin off another simulation and come back and take a look at it. So I think the bare metal is really key to all of this.
Got it, got it. And how does D3 View fit into this entire sort of end-to-end pipeline of moving data, staying close to the data, running simulations, doing analytics on top?
So our starting point really is we want to make accessing HPC simple. And so we take care of all the configurations, we take care of, really talking to the cloud provisioning systems and managing that. That part is very simple. And the second part of it is, how do you track the progress of simulations? If it's a 20-hour simulation, you don't want to wait until the 20 hours to look at what happened to it. So constant feedback while the simulation is running is critical. And maybe perhaps you're looking to reduce force by 10% and you couldn't do it and you detected it early. You can kill it and then you can run another simulation. So that interaction is very key. So we help in increasing the number of simulations, by allowing them to interrupt them. Once the simulation finishes, it takes about 2-3 hours for any engineer to analyze that particular data. And we bring it down to 0 almost, because we run our calculations right on HPC and we have intelligent systems to detect what kind of simulation it is, what product it is, what load case it is. And so we can do all of that behind the scenes. And when he looks at the data, he can make a quick decision. It's a good run, not a good run, what changes to make.
So how does somebody get access to D3 View, and also, where do the ISVs play a part in this? Because we talk to a lot of HPC customers, and they're like, I use every software and every solver on the planet. So I'm guessing D3 View is that core sort of fundamental glue that allows you to do everything end to end.
Absolutely, that's a very key component. Customers pick what solvers they want to run because they're happy with maybe legacy data. So we are kind of neutral to every solver that there is. And we also support communication between multiple solvers and exchange of data from multiple solvers across different groups. So we're kind of neutral, in that sense.
How do I get access to D3 View? Is it sort of like a web portal? I just go sign up? Is it more sort of managed in the sense that you completely obfuscate the cloud provider, the ISVs, et cetera, and you just manage the whole view? Is it pay per job? Like, how does that all, how do the economics of this work?
Absolutely. So if you're going to start something, you're probably going to start something without an on-prem system. So naturally, you want a system that's in the cloud. And so you can talk to us and we'll kind of assess what your needs are, what kind of typical, simulations you're looking to perform. And we, keep the cloud interactions behind. I mean, if the customers have a certain cloud preference, we definitely work with them. But if they don't, then we provide sort of a comparison and we let them pick one. And from then onwards, we really onboard them quickly and we onboard the rest of the solvers, connect through a VPN or maybe, bring them on the system. So that part, and then gradually, maybe you will look to get an on-prem system. We can help you there as well. We have, relationships with vendors who can help us. So we kind of allow you to bring that environment back to your on-prem and have a relationship where you have an on-prem and burst into cloud. So we help in that setup as well.
Fantastic, fantastic. Well, Surya, I know we can talk about this like all day long, but again, thank you for your time today, and we'll catch you guys another episode on Kicking It with Karan.